Okay everybody, welcome back. In this video we're going to finish up our information for section 5.4 of AP Calculus using the first derivative test to determine relative or local extrema. In the last video we introduced you to all the different aspects of the first derivative test that we needed to consider. And in this video it should be a fairly short one. We're just going to work through one more example. Example 3, where we are supposed to find the relative maxima and minima of the function h of x equals x squared over the quantity 2 minus x. So the first thing I need to do in order to find my relative extrema is I'm going to need to identify my critical points, and in order to do that I need the derivative. So that's where I'm going to start. H prime of x, I'm going to use the quotient rule here, low times the derivative of high, minus high times the derivative of low, square the bottom, and away I go. And if we simplify this, we've got h prime of x equals, let's see, 4x minus 2x squared plus x squared all over 2 minus x, the quantity squared. And so we end up with, let's see, h prime of x equals 4x minus x squared all over 2 minus x, the quantity squared. And if we go ahead and solve this, if we set the numerator equal to 0, we figure out where the derivative is 0. So we set 4x minus x squared equal to 0. We solve for x, and that is at x equals 4 and x equals 0. Are two places where the numerator is 0, and the derivative is undefined at x equals 2, because that makes the denominator equal to 0. Okay, so here we go. We set up our sign chart for the derivative h prime of x. And we'll put our separators over here. And now we're going to go ahead and analyze the sign behavior of the derivative. It might be easier for you, depending, to think about this function as such in order to do our sign analysis. I know that's how I would prefer to do it. So that's what I'm going to do. I'm going to go ahead and substitute a value in from the interval from 0 to 2. I'll choose 1. If we put 1 in here, that's positive times positive over positive. Positive times positive is positive over positive is positive. For this interval, I'll pick 3. If I put 3 in here, I've got positive times positive over negative. Positive times a positive divided by a negative, right? Oh my goodness, I took away my square on the denominator. I was like, what is going on here? I think this should be positive. And it is. Positive times a positive over a negative squared, which is positive. So that makes this positive as well. All right, end interval. If I put 5 back into this derivative, I've got a positive times a negative over a negative squared, so I've got a negative over a positive. That's going to be negative. And out here, let's use -1. That's negative times a positive over a positive squared, so that's a negative over a positive, so that's negative. So I have a relative min of something, and my relative min occurs where I have sign change from negative to positive. So I have a relative min at x equals 0. In order to get the value of the relative min, I'm going to substitute x equals 0 back into the original function. That gives me 0 over 2. So the relative min of 0 at x equals 0. At 2, I have no sign change, so I don't have an extreme value there. And at 4, I've got a sign change in the derivative from positive to negative. Therefore, I've got a relative max there. If I substitute 4 back into the original function, that gives me 4 squared is 16 over negative 2, so that's negative 8. So I have a relative max of negative 8 at x equals 4. Sometimes you might see people write, relative max and mins, especially if we're talking about graphs. You might see them write those as ordered pairs. I usually do that when I'm talking, when I'm specifically focused on what's going on in a graph, whereas this I might use more in like an applied problem solving kind of situation. And we have no extreme at x equals 2 because h prime doesn't change sign. And also, not only does h prime not change sign there, but h of x doesn't exist either. Because if I put 2 back into the original function, I get 4 over 0. So it doesn't exist there. So one of the things that you might think is a little weird about this is we've got a relative max that's larger than our, that's smaller than our relative min. If we take a look at the graph of this, let's go ahead and graph the function y equals x squared x squared over 2 minus x. Type that in right? Yep. All right. So there's our function. Now, our information told us we had a relative max of a relative min of 0 at x equals 0. So there we see that. There's a relative min of 0 at x equals 0. And it tells us that we have a relative max of negative 8 at x equals 4, which we can't see on our screen, but if we scroll up a little bit, there we go. There we see the relative max. And that's how you end up with a relative min that's bigger than your relative max, is when we have a discontinuity here in the function and see something like that. All right, I don't want to get too bogged down into that. That gets us to the end of our video for today. So go out and practice using the first derivative test to determine relative extrema. And next time we'll be back to talk about using the candidates test to determine absolute or global extrema. Okay, see you then. Have a great rest of your day.